Hello everyone, my name is Naren, and in this session let's talk about system design for movie tickets booking platform like BookMyShow or Fandango. Designing a highly scalable system is pretty complex and it takes years to perfect. Also, designs are continuously optimized and tweaked continuously over many years to get a highly scalable, high available and fault tolerant system. Now, without wasting much of our time, let's jump right into system design for online ticket booking platform. Going forward, I'm going to mention online ticket booking platform as BMS as a shortcut, and BMS stands for Book My Show. It is number one movie tickets booking platform in India. So any basic system or a tickets aggregator platform looks something like this. A user requests a ticket through an aggregator or a BMS. And the BMS in turn places a request for a seat or a ticket for a particular movie from the theater. And how the system works. Let's talk a little bit about how this part of the world works. With that in mind, any third-party ticket aggregator who supports booking tickets should work with this database in the theater site to get the information or place ticket booking. Now, if you have booked a ticket on any of these platforms, you would know that you can actually see the available and unavailable or already booked seats of a theater. And how does this platform know what seats are available and what seats are not available? So there are two strategies again to know that information. So the first one is connect to the theater's DB directly. That means you can every system connects to the DB and reads the tables of the DB and use that information by caching to show to the customer which visits to a specific platform. That way, user can immediately know what seats are available and what's not. The second strategy is, instead of connecting directly to the DB, you can use the theater's API. That means this server would have exposed some API like get all the available seats in a theater and get all the unavailable seats in a theater, and one more API to book a theater, one more API to lock. So when I say lock, why do we need a lock? Say there are obvious situations or scenarios that multiple users from different platforms trying to book a same seat or to acquire a same ticket. That means we need a locking mechanism. So who should handle that? Definitely these guys cannot do that. If we go with the second strategy of anyone can book any tickets available in this DB, that means that this server should take care of locking a particular seat. So if say for example, if a user from BMS trying to book a seat number 1, and if another customer from Paytm also trying to book the same seat, and one more guy from Fandango also is trying to book a seat number 1, that means this server should take care of locking the seat for the user whoever came first. That means if the user from the BMS came first, that means this seat will be reserved for the user who came from BMS for about 10 minutes. If the user didn't book the ticket within 10 minutes, that means this seat will be marked available, and then any other user from other platform or the same platform can book the same ticket after 10 minutes. If you are using this strategy, that is using Theater's API, that means you will be making a lot of requests, that is IO calls, that is network IO calls from your server to the Theater server. So that means you should be using Python's async if you want to build your server using Python, or if you want to use Erlang, you can go with lightweight threads, or if you want to use Go, you can go with Go coroutine. These works a lot better when you are making a lot of network IO or requests from your server. Now, before designing the actual system design for BMS, let's list out all the features which we want to support in this system. As usual, if you guys don't know the features or if you have any confusions around what features to support and what not to, talk to your interviewer, get it clear, and then you tell them that you're going to support these features, and if he has any problem with that, he's going to add what features he's expecting for you to support. So now I have already listed down all the features which I'm going to support. So now let's talk a bit about all these features. Okay. So now the first feature is highly concurrent. BookMyShow in India books about 90,000 or 95,000 tickets a day. That means too many of tickets booking happening. Apart from tickets booking alone, there are people who are reading comments, ratings, and then just coming here to see tickets availability and etc. Right? That means too many requests are happening. That means we need to make our system highly concurrent. The second one is responsive UI. Users are coming from different kind of devices like mobile phone, applications, tablets or desktop. Our UI should be able to make user experience better using responsive UI. So third is this BMS not just supports one city, it supports all the cities in India or any other countries like Africa, New Zealand, and etc. So the same system should scale to support different countries and cities. And it should also support digital payments like cards, credit card, debit card, or wallets, or bitcoins, and etc. So the fifth one is movie suggestions. So if a user watches some kind of sci-fi movies, then the next time our system should automatically suggest the user that another sci-fi movie has released and you might be interested in watching that movie. So we need to support movie suggestion feature as well. So the sixth one is comments and ratings. So people should be able to write comments about the movie they have watched and rate the movie also. Seventh one is movie info. They should be able to see the crew, cast, pictures, videos, and trailers of the movie. So we should have a profile for a movie. So the eighth one is the system should send offline copy or a copy of tickets via SMS, email, or via WhatsApp. So with all these features, let's draw the system design on the board, and I'll explain every components individually. And here we have the system design for BookMyShow. Now let's talk about each and every individual component. This over here is mobile app or application, and this is the desktop. There can be two different places from where the users are visiting BookMyShow, but the same application server serves the purpose. Okay, so let's talk about load balancing. Obviously, we need load balancer to keep highly concurrent system when we are scaling the app servers horizontally. So the load balancer have different techniques to balance the load. That is, you can use consistent hashing to figure out which app server the request should hit, or you can go with round robin where the requests are done like handover in a round robin fashion, or you can use weighted round robin, or you can also go for least connection based strategy to do the load balancing. And going forward, this here is the front end caching system called Varnish. It helps you, the cache cannot only improve your UX but also help you to relieve the pressure on the overall backend infrastructure over here. Also, you can use CDN to cache your pages or APIs or any video or image content. And next is the app servers. Here you can see there are multiple app servers over here. I'll mention it as app server. So you need to scale these app servers horizontally to take the heavy load or to handle a lot of requests in parallel. So specifically, BookMyShow uses Java, Spring, Swagger, and Hibernate in the app server, but you can always go with Python-based servers, or you can also try Node.js for that matter. There is no specific answer that you should use this language or this particular framework. It all depends on the requirements. So the next is to support search APIs for your to search movies or to search plays or shows. What you can actually do is dump all the data into Elasticsearch over here. Elasticsearch is really good. It is distributed. It has RESTful search APIs available in the system, and it also can be used as analytics engine, which works and scales as an app level search engine to answer all the search queries from the front end. So the next thing you can see is cache. Cache is very important to save all the information related to the movies and sometimes even the seat ordering or the place by theater or a lot of information. You can actually use cache. You can use memcached or Redis, whereas the benefit of using Redis is it is distributed and persistent. So going forward to the DB, you can't just use one kind of DB, that is RDBMS or NoSQL. It always works good with the combination of RDBMS plus NoSQL. So what we can actually do is, in case of this particular BMS or ticketing system, we need ACID property and relationship representation, because the relationship will be something like you have a country, city, and city has so many theaters, and each theater can have multiple screens in it, and each screen has multiple rows of seats, and then a different tier of seats and many number of seats, right? So there is a proper relationship, and also there is a movie and to be attached to the same relationship. So we need a proper relationship to handle these tons of data, right? So, and also we need to handle transactions. So RDBMS is good since the data won't grow too much, because the number of theaters and screens and the seats mostly remain constant. Upon addition of new theaters and new places, only the data will increase. So it's good to go with RDBMS like MySQL or Postgres to save relational data. And also we have tons of data like movie related information, like from trailer, actors, crew, comments and reviews. These cannot be saved in RDBMS because these can be considered as big data, or it's too much of data for RDBMS to digest. So what we can actually use is any kind of NoSQL database where it is distributed by geo. Like Cassandra you can go with, which is pretty good at holding this kind of big data, like all the comments, all the reviews, all the ratings, the crews, the actors, and the movie information. So and also what you have to do is RDBMS also you need to have a sharded data by geo, and also you can either go with master slave architecture, where slaves can be used for reading as a read nodes, and master can be used for writes. That way you can easily scale RDBMS as well. So apart from that, we need to have, so now the benefits of using NoSQL also is, so since our nodes are distributed across geo, and we can set the replication factor, and that tells you how many copy of the same data can be saved, and also the consistency level. That way you can always be sure that we won't lose the data, and 99.99% availability and durability also. So for example, if these two nodes goes down, still we have the data in all the other three nodes. Going forward, let's talk about the async workers. You can see over here. So why do we need async workers? So many times, say for example, a user has booked a ticket, so we need to generate the PDF, or we need to generate the PNG of an image, and also we need to send an email, send a SMS, or send tickets via WhatsApp. So all these tasks are like making third-party API calls. Say for example, to send an SMS, we need to make a call to Twilio, or to send an email, we need to make a call to email server, right? These are like network IO. They add a lot of latency. So in the same API request for ticket booking, we can't execute all these tasks synchronously. So what we need to do is, as soon as the application server confirms the booking of a ticket, then what they do is they add a message into the queue that ticket has been booked. Now you need to do the routine work like sending the ticket via email, SMS, or sending the ticket via WhatsApp. And also you can do is send GCM notifications saying that your ticket has been booked successfully. So all this time-taking task, a message will be added into the queue. Any workers which is free will pick up the task and they start executing the time-taking task asynchronously. So for this part, you can use Python Celery, which we use heavily in a lot of distributed asynchronous systems. And also there are similar kind of distributed asynchronous workers available in Java, Go, and etc. So you can use any of that. All works well. So moving forward, let's talk about business intelligence or recommendation engine, which we spoke in the feature, in the list of the features. So to do that, we need to obviously have a Hadoop platform to get the business intelligence. So what we do is all the logs, all the user activities, all the information can be dumped into Hadoop HDFS as a dump of log file or something. Then on top of it, we can run big or high queries to extract the information like user behavior or user graph, or so we can train our machine learning model using the same data to recommend movies for the customers or the users. So in the meanwhile, we can use, say, something like Kafka in between, Kafka queue in between, and feed the data into Spark to do something like real-time analysis. We can either use Spark or Storm over here to get the trends or latest trends or what's happening in the system, and also to understand the user activity and behavior. And also sometimes we can do figure out fraud detection and mitigation strategy using the Spark and Storm stream processing engine. So that way, that's about it. So moving forward, what we can do is, here you can see that there is a payment gateway. This we can go with a third-party payment gateway, like for example, BMS uses JustPay, which has a lot of different vendors, credit cards, banking application, banks, and all the different wallets. So we can when there is a ticket request to book a seat, so we can redirect to the payment gateway, and once the payment is confirmed, we can issue the tickets using a synchronous worker and a copy of tickets in the synchronous API call also. Now let's talk about the working steps. What happens when a customer comes to BMS and books a ticket? So the first step, what he is going to do is, customer comes into uses the application. He does the location filter and sorting and going into the movies to the specific movie. So to find the location, what we can do is, if it is a mobile phone, we can use the GPS location available in the mobile phone, or if it is a laptop, we can use the ISP, Internet Service Provider based, IP based location strategy to figure out the location of the user, and we can suggest all the nearby theaters and the movies which is released in that particular area. So then when the user selects a movie, he checks the different timings available in that theater, and the next thing what he does is opens a particular timings of a theater, and then he sees all the available and unavailable or booked tickets, seats. Now what BMS should do is should also lock the seat for the next 10 minutes. What it does is BMS system makes a call to the theater, which I showed you in the very beginning of the video. It makes a call to the theater DB to block the seats. So now the ticket is booked temporarily to a user trying to book. So every other app in the theater or other system or the other aggregator can't book the same ticket. Now the user can proceed to book the ticket, or the ticket or the seat will be reopened if he didn't book it after 10 or 15 minutes. Now what it does is, if the user continues to book, he will check the invoice with the payment option using the payment gateway over here, and then the request will be processed, and then a callback will be happen to the app server saying the payment is processed and successful. So once the payment is successful, the theater gives you a unique ID, and that will be received in the app server. So what BMS does is, using that unique ID, a ticket will be generated, QR code, which is attached to the ticket, and a copy of ticket will be immediately shown to the user, and also a message to the queue will be added to send the same copy of tickets with the information like date, time, place, QR code, and the address of the theater, and everything will be sent via email, SMS, or the tickets. So now what happens is, when the customer goes to the theater, he shows the QR code, and the same ID will be also saved with the theater. So they both match the ticket ID, and then the user enters the theater. So yeah, that's the overall flow of how user interacts with the system. BMS is built entirely on Amazon platform. It uses microservice architecture, like every component is separated out and they run independent of, they are not monolithic architecture. So all these app servers and the workers are hosted on EC2 instances of Amazon, and the CDN is Cloudflare, and all the trailers, gallery are saved in S3 of Amazon. BookMyShow's UI is built on top of React.js, Bootstrap, JS, and CSS. The server they use is Java, Spring Boot, Swagger, and Hibernate. So the database which they use is MySQL, and the server I haven't shown here is used Tomcat. For the caching, they have used Hazelcast. For all kind of distributed system, they are using RabbitMQ over here, and the payment gateway they are using JustPay. For the deployment of the whole different microservices, they use Docker and Ansible, and along with that they use Git to maintain the code base. For logging, collection, and monitoring, what they do is all the logs are pushed to Logstash, and Logstash can read from syslog, log file, or queue, and everything. All the logs will be sent to Logstash, and Logstash, based on a lot of filtering conditions, will be redirected to Elk Stack, or does a lot of different actions, like it can send a notification via HipChat, WhatsApp, or it can even raise Jira bug. Based on the filter, the logs will be redirected to Elk. In here, on Kibana, we can build a dashboard to see what is the error rate and etc. So apart from that, the load balance which they use is Nginx. And that's it. Let's see what are the tables which we needed for the system design, which we just saw. So obviously we need a table with place. The same table can be used to save the hierarchical data for any given theaters, like country, state, city, and the street where the theater is. So that will be one-to-many relationship, and every theater will have multiple screens in it, so we need to have one-to-many relationship between theater and screen. And each screen will also have different tiers of seats, or different kind of rows of seats. So we need multiple tier, and then every tier will have different seats. So the pricing for different tier of seats varies. So this is where we can handle that. So each tier will have multiple seats. So also only one movie can be played in a particular screen at any given point of the time. So there will be only one-to-one relationship between screen and a movie. We also need an offers table that contains all the different offers available for a particular movie, or it can be for a particular screen, or it can be for a particular seats. And also we need to have a user table which contains user information, and one user can book multiple tickets, and each ticket can have multiple seats in it. So this is the high level database table structure. Here are the list of tables which we need in NoSQL database. The tables depends on the queries. In NoSQL, we need to anticipate all the different queries, and we have to do the data modeling based on the number of queries which we are going to support in the system. So, and also you can see that there are no relationship between the tables, as in NoSQL we can't do join and we can't maintain the relationship. And here are the high level tables which we need to have in NoSQL. Like we need a table to save all the comments for a given movie, and we need a table to save all the ratings for a given movie, and also we need a table to save information about the movie like description and synopsis, etc. And we need a table to save all the video and audio information, or the path to the images and the videos of a given movie. And we need a table to save artists related information, and we need a table to save cast and crew, and we need a table to save all the reviews about the movie, and we need a lot of many different tables to save analytics data which will be consumed by the backend team. System design is not simple. System design is subjective. It depends on the requirements, features, it depends on the location, kind of user base, and etc. So there is no such thing as ideal system design for a particular system. System design evolves by time, and it gets optimized and tweaked. So if you guys like this video about system design for BookMyShow or ticket booking platform, please do subscribe to my channel and leave a comment and share this video with your friends. Thanks a lot.